So, thank you. I'd like to welcome you I'd like to welcome you all. God damn it. Great start. So, my talk is about your first PHP extension. And no, the chemist is not a typo. It's actually stolen from the title of a book by Robert Boyle. It's about alchemy for the skeptical chemist. And this is like the turning point of where historical experimenting turned into proper science. And it will become relevant in this talk, but I won't bore you, promise. So, and now I have to turn on my clicker. And yeah, my name is Christian. I'm resident madman at Shopware. I'm the one who tries all the weird stuff, like writing PHP extensions in Rust. You can find me on the Bird site as well as on Mastodon. And today what I want to show you is how we can capture lightning. So what you see here is a painting of the discovery of phosphorus. This was done by Henning Brandt in Hamburg around 1669. And what you can see here is a guy that boiled down 5,000 liters of urine to arrive at a flask that is glowing and bursts into flames due to all the toxic chemicals he managed to release. That's also why he looks so surprised. And the thing is that alchemy can be dangerous, and we want to do it in a safer way, but we still have the same general idea. We still want to achieve the same goals, because we want to pierce like the crust of our normal environment and figure out how nature works. And we want to do this today with Rust. Sorry, not with Rust. We want to pierce PHP and then discover the rules of PHP in Rust. So, but to discover new things, we need a laboratory for that. And in the olden days, they might have looked like this. It's pretty cramped, it's cluttered, nobody uses namespaces, everything is on one heap, and the type system is pretty rudimentary. Still, you can get a lot of good science out of using the old style like this. But nowadays, we have nice laboratories with things like fume hoods, so you don't accidentally gas yourself. And the same way, I want to show you, first of all, a reproducible build system that uses the Nix ecosystem to declaratively set up a development environment and then use that development environment to actually run and compile the Rust code. So, for that we are using devenv. Devenv is a tool that's quite young. It's, you should definitely look at it because it's very useful for PHP projects in and of themselves. And it is built on a very mature technology, which is the Nix build system, which has been around for almost 20 years now. So, in this devenv file, we will configure our development environment. This is a Nix expression, so the content of our devenv.nix, and we will start with the quite simple and obvious. So we want Rust, so we enable Rust. This gives you all the tools you need to use Rust. It will give you Cargo, the package manager, basically the equivalent of Composer in Rustland. It also gives you rustc. Rustc is the compiler and the actual executable, which is kind of equivalent to PHP. And if you heard this before, you were at Nunu's talk yesterday because he made the same metaphor for it. But this also installs things like the Rust language server. And the Rust language server is like an IDE framework already built into the language and into Cargo. And while a separate project, it is like the main way for editors to understand your Rust code. So you can just install VS Code or Vim or whatever additionally, and then your editor can use the Rust language server to get inspection information, auto completion, things like that. And all the configuration for that is already done by enabling the Rust language. Next up, we want PHP. So to use PHP, we use quite a bigger expression. This is the whole expression that defines PHP. Well, not quite. There's a little caveat I'm going to talk about soon. First of all, obviously we enable PHP. But after we enable PHP, we need to define what kind of PHP we want to use. This is the isolation I talked about previously. So devenv allows you to specify specific packages and specific versions and specific setups of PHP. And in this case, we are using a wrapper, it's called, so PHP unwrapped build environment. So we are calling the function build environment to create our development setup for PHP. What this does is it leaves the all the PHP source code intact, so you can still link against it, so you still have the PHP headers in your path and things like that. Also, what we then do is we will add the extensions. So you can define an arbitrary set of extensions from all the possible extensions. But for this example, I just need readline because I developed this together with a REPL, and for the REPL you need the readline extension. Also, you can add custom PHP configuration. This will end up in your conf files, or in your ini files. And yeah, I'm just setting the memory limit to -1 because who doesn't do it? So then we can actually start developing our Rust program. So we made our nice little folder, and we can call cargo init, which will initialize a Rust project in the folder where we currently are. That's why there's the dot. But we also pass it the parameter lib, because the PHP extension system works by including a shared library, so like a binary that has no main function. And to create something like this, we need to tell cargo about it, and that's why we call it with a --lib, which means it creates a library with a lib.rs file instead of a main.rs file. But that is in theory enough to get started developing an arbitrary library. The only issue is if we would now start and try to develop a PHP extension, we will end up with quite a lot of pain, because we have to do all the interfacing with the PHP engine ourselves. We have to write our own abstractions that take the basic C code and the header files and all the API that the engine provides to Rust equivalents. And apart from the fact that something like this would definitely not fit in a 45-minute talk, there's people that have already done this for us. So let's have other people experience the pain, and we just come in afterwards, nice, and have fun developing an extension. And for that, we are using the crate. So crate is like a package in Composer or a library in general languages. We add our extension PHP rs crate, and this will provide us with an API to nicely and natively for Rust interact with PHP engine. So let's have a look at the actual code in our extension. Once you initialize a library, you will only get a few files, so cargo configuration, things like that. I'm leaving that out for time's sake, but also because, frankly, you can look it up, and I will provide you links for it at the end where you can look it up. But you will also create a lib.rs, which is the entry point for our library. And how do you start any good project? Of course, with a hello world function. So now we're going through the actual Rust code. And while this isn't a general introduction to Rust, I will go with you through all of my slides, and I will show you what every line of this code means. So, first of all, similar to PHP, we need to include all the files that aren't part of our project yet. We need to include all the files which contain things we want to use in our file. For that, we have the use keyword, and what I include is everything in the prelude namespace or the prelude subcrate of the PHP RS crate. The asterisk just means import everything, because the prelude one includes all the generally useful and necessary items to start developing a PHP extension. And also, just for your information, I will skip the includes for the rest of the slides. This is just, you get a feeling for it, that it's quite easy to get started, but it would just clutter the slides afterwards. So, our first function, hello world. I mean, I guess you're all familiar with functions, I hope, but I will still explain how they look in Rust. So, as you can see, the first keyword here means pub. Pub means it's a public function. Because we are talking about a shared library, Rust can decide to either add functions in that expose functions through that shared library or not. And the pub keyword means it will expose this function in the shared library. Fn is just a word to say, hey, here comes a function. Hello world is our name. I guess you figured that out. And then we have a parameter called name, which will take our name for the person we want to greet. And now comes the interesting part, because the parameter has a second part. And this second part is called a reference to a string. Now, Rust has a concept of own types, so values that represent their data, but also references, which are variables that represent just a pointer to a value. This is quite an important distinction in machine close languages, so in systems programming languages, and this allows you to be way more explicit with how your memory is laid out and where everything is. So you don't need to copy data all the time. And then we get the arrow, and the arrow just means everything after that is our return type. And in this case, our return type is string. Now you might ask, why is name a string when it's a reference and like totally weird? And why does string look like a normal class or a struct? And the thing is that the reference to a string is like a historic thing in Rust because it also implies some other things. But honestly, it's just a bit of an inconsistency, which I guess as PHP developers we're all too familiar with. And that means this is a reference to a string, and you can't mutate the string, and you don't have to copy the data. Whereas this means what this function returns are the actual bytes of the text that you return, of the string. Also, that's a little simplification. It's a bit more complicated under the hood, but it will suffice to understand the rest. So what does our function do? Our function prints hello name. This is called a macro. That's why there's an exclamation point. And what this means is this can kind of break the normal language rules to like automatically construct something. And you give it a formatting string, so kind of like printf, and the placeholder will be replaced by the variable. And another thing that you might notice is no semicolon at the end. This is also like a special marker in Rust, because this means that the last statement in a function without a semicolon will return. So you can keep the return keyword away and just say, hey, my last statement without a semicolon. So the value of the evaluated function here becomes whatever is the result of the evaluation here. Now that is all fine and good, but how do we get it in PHP? And I guess you spotted it from the first moment I talked about this slide, which is this attribute. This attribute means that this function will be exposed in a PHP conformal way. So for a C function or for a machine function to be callable by PHP, it needs to conform to certain to a certain schema, to certain requirements. And normally you would have to write all that glue code yourself. But the XPHP crate allows you to just annotate an attribute to a function, and then during the compilation, this crate will do all the necessary steps to generate a proper wrapper to take a PHP string, take a reference to its contents, and then use the returned value of string to create a new PHP string, register its contents with the PHP engine, and return it to like userland again. That's not all, because in general, when you are installing an extension, PHP needs to know what the extension does, like what it's called, what the functions are, what classes are, things like that. And for that, there is a config function that you canonically like give it the right name, and PHP will call it. But in our Rust example, we can just write our own configuration function, again, just a public function. It takes a configuration builder, and then you can modify the configuration builder with things like different names, different class entries, etc., and return the module builder then, so that the PHP extension Rust crate will create a proper extension from that. Then we just annotate it with the PHP module attribute so that the compilation step knows which function to evaluate for that. Okay, that was quite a sprint. And I've promised you we're going to capture lightning. So you might ask, what kind of lightning? Well, we're going to capture Lightning CSS. Who here heard of Lightning CSS? Ooh, at least a few people. So, for everybody else, Lightning CSS is a CSS parser, transformer, bundler, and minifier for the Parcel project, and is implemented as a Rust crate, but also then exposed as an NPM library and a binary. And this allows you to take your raw CSS and bundle it and minify it and also apply it to different browser targets, all very quickly and in one go. And we at Shopware have a theme system. So what this means is people can customize their shops by uploading plugins that contain themes, and these themes need to be compiled on the fly. And for that, we also have a CSS prefixer and minifier and bundler and things like that, but they are currently implemented in PHP. And now I figured it would be kind of fun if we could use a Rust library directly out of PHP. All right, but now that we know what our Lightning is, we need to somehow get it. For this, we can just call cargo at Lightning CSS. Lightning CSS is just another crate, like a composer package. You can require it and then add it to your project. But how is this then going to look in practice? So we've got quite a bigger function now, although it is still conceptually pretty close to our hello world function. To start with, let's again go over the function header. We have a function called transform. This will transform our CSS. No surprises there. You give it our style. So our CSS, again, as an immutable reference to a string, because CSS, as you all know, is a text format. You just give it that. Now here comes the first really new part. We no longer return a string, but we return a result of string. And a result we'll get back to later, but it symbolizes a fallible operation. So it represents a function call that can potentially error out, create an exception, etc. The next thing then is we need to actually get our CSS into like Lightning CSS. And Lightning CSS for that provides a style sheet namespace / struct. And this struct then can be created from like a ball of CSS and some parser options to configure how it's going to parse that CSS. But in this case, I'm just going to take the simple route and just call default, because, I mean, what am I? Reading documentation? Like, no. Then we actually come to the important bit, which is we want to minify it. Again, with the default options, that's good enough. We'll get to those later. And then, last but not least, we need to tell PHP again, like how our CSS looks. And for that, we are returning a result. So again, a wrapper type, a generic type, and our result can have two different states, so OK and error. This is the OK return, so this means our computation did not fail, it succeeded. And we are going to print our CSS to a string, but then also allow it to minify. So for once, I'm not using the defaults untouched. I at least specify that I want it to be minified. And so we pass it the config, we get back our result, and then we access the code field of that result and return it. So we've got a string of our minified CSS. So let's get back to our result. As I said, it's a fallible operation. So what does fallible mean in our context for our transform function? It means that it can crash, or not crash, but it can stop working if, for example, the style sheet encounters a parser error. So, for example, if the CSS is malformed, or if the CSS is malformed, or maybe there's like an error in the read process and you don't have a full string, things like that. But now we are hitting our first roadblock with this map error function, because the result type I've inherited from a library or a crate called anyhow, which makes our our result handling a whole lot easier. And the thing is that when the style sheet parsing crashes, it wants to return a very speaking and a very helpful error. For that, it references the part of the style sheet that produced the error. So the problem is that when parse has a problem and returns an error, that error still contains a reference to the string. And we can't just return something that contains a reference to something wholly else that we kind of did in the middle of it, because then Rust cannot track its lifetime. It does not know when to clear up the memory. And for that, I'm doing a very quick and dirty way. I'm creating a new error from my old one, which is just a string representation of the old one. So basically, I'm just saying, hey, print me the error description, put it in a new box called error, and then we return that. And this returning of the error is also what the question marks are for. You may have noticed them before, but these are the syntactic sugar that makes Rust error handling quite comfortable, even though Rust doesn't have exceptions. So in PHP, you can just throw an exception which will automatically unravel the whole function stack until the point comes where it is either at the top level or it is catched by some catch block before. In Rust, you don't have the concept of an exception, at least not properly. You have panics and stuff like that, but let's not get into that. And the question marks are a shortcut for if you encounter an error at any of these points, you will just return the error value as the result instead of the actual OK value. And this also means that every time at these question marks, below them, we can be sure that whatever the function returned was OK and is unpacked. So style sheet parse returns a result CSS. But here we have a plain CSS because we could safely unwrap it after the question mark, because if it would have failed, it would have already returned the error. Okay, now, there's more ways to capture lightning. And this is why I totally forgot that I highlighted OK. So, sorry for that. Now, there are other ways to capture lightning with another angry element. I think we've talked quite a bit about how we build a simple function to minify our CSS. But we started with alchemy. And I want to know, just segue a bit away, and show you how modern scientists can capture lightning with oxygen. And oh my God, this didn't work at all. So you see this angry red glow down here. And this angry red glow is how modern scientists create lightning in a bottle, because they just take two very reactive chemicals, so oxygen, which is dissolved in here, and pure chlorine, which is incredibly reactive, and blubber it through there till it starts to glow. And what this glow means is that the oxygen is very angry, because the chlorine just rips off electrons and leaves it in a state it normally is not available in. And so it returns a red glow. And so I want to show you now how we can capture lightning in a more modern way, because at the end of the day, we are at a serious developer conference, and as we heard in the keynote today, we want to improve our quality of life. So I'm now going to show you how we do it the object-oriented way. And for that, we obviously need an object to present as. And for that, we create a CSS transformer. Now, the thing at the bottom is the struct definition. So structs are look in some ways similar to PHP classes, but they are not quite. The difference is that a struct is has a defined memory layout and is only about the data. So structs only contain data, functionalities, method, things like that are only added in later as a separate thing, kind of. So we have our CSS transformer, and we want to configure it. So in Lightning CSS, you can configure for which browser versions you want your CSS packed. And for that, we give it the browsers list. The browsers list is a type provided by Lightning CSS, and it's a struct containing all the versions of the browsers as integers, which will bite us later, as I'm going to show you. And we have a minify value because maybe for debugging purposes, you don't want to have your CSS minified. Still, we have a struct, but it's not in PHP. That's why we have the PHP class annotation. As you can see, you can give annotations parameters. And in this case, we can give our class a name, or sorry, our struct a name for the PHP class. And the great thing is that namespaces are just part of the string. So you don't have to create like a separate namespace object or something like this. You can just add in the backslashes, and we have our Flash CSS transformer, and we can use it from PHP in the future. So, but we don't have much use for a struct without any kind of interactivity. And for that, we are going to implement some methods. This is done in Rust through an implementation block, an impl block. And we implement the behavior of the CSS transformer. This is what I mean by having structs as a separate thing. So you have data on the one hand, and you have the general behaviors of it separately. This also comes into play with things like the type system, the trait system, stuff like that, but let's not get into it yet. So we want one method and one static construction function. The thing that makes a method in Rust is because it is passed a self parameter. Again, this might be familiar if you've seen yesterday's talk, but let me explain it again. The self parameter is like a magic variable name. So every time in an impl block, Rust encounters a self variable. It knows that this variable references the actual instance of the struct you are calling it with. This is the equivalent of PHP this. Except in Rust, you can also specify what kind of reference you want. So either an immutable reference like this, but you can also have mutable references, or quite elegantly, you can also take ownership of the value itself. So you can build a function after which you have no longer access to the object on which you called the function, the method. And this is especially useful for things like state machines. So you can basically eat up a state and return a different state, and they are on a type system level split up from each other and irrepresentable as wrong states. But let's not get too deep into that, because we also have a constructor. We have a PHP implementation, as I already said. We have a PHP constructor, and this is also just magic done by the impl annotation. It detects that you have a function called construct, like in PHP, and this will return a struct of type self. So in this case, self is like a magic struct definition, and it always refers to the struct up top in the impl block. Now, let's have a look inside the constructor. It's very complicated. It instantiates a struct. It uses the browser's default list, sets minify to true, and that's it. That's the whole of the construct function, and the PHP crate will do everything to wrap it up, register a proper class name, and also create a magic function to create the PHP class with the data returned by this Rust function. Now, we also have a transform method again, and in this case, we want to actually use the configuration that we store inside of the class that we created, inside of the struct. And for that, we are going to reference the self variable again. And let me show you how you can access the data inside of a struct. And in this case, we can just reference self.minify. Minify is a bool, which means that Rust automatically knows what to do if you want to copy it. It's a bool, you just have to copy a byte, and then you can take the byte out of self.minify and put it into our config for our Lightning CSS. The parts I've left out are just the same as in the function version, so in the non-OOP version, and these are just the changes that we made to that. The next thing is, which is a bit more complicated, is browsers is a more complicated type. It's a struct. And so Rust does not automatically know how it can easily replicate the value. It needs to do some memory cloning. So it needs to iterate through some bytes and fill other bytes with that content. And for that, we call clone. Now, why do we even have to do that? That is because the minify options wants the target's value, not a reference to a target's value. It wants the value itself. And so we have to clone the value because we only have a reference to ourselves. And unlike in JavaScript, you cannot scope the mutability only to the upper parts, but it will automatically move down through all the structs. And then again, we wrap it in sum, which is like a nullable type. So in PHP, we can type in my class name null. And in Rust, the equivalent would be to define it as optional. And optional values can have sum as a value, which means there is actually something. The alternative would be none, which means there's nothing. Okay, so how does this look in practice? Like this. This is now the PHP code we can create with that. We can instantiate a new transformer, which I've misspelled, great. And this this object now has the ability to transform our CSS according to the configuration we created in Rust. And then it also returns the minified CSS. As you can see, there's just one little problem. Our configuration is still in Rust. We can't access it from PHP. And for that, wouldn't it be great if we could just define the configuration on creation of the transformer? And for that, we have to modify the constructor again. So this time, our constructor actually gets a parameter. This parameter is one of those optionals I've talked to before. So this means we can leave it out if we want the default config, but we can also provide one. And the configuration is provided as a hash table. And here is the first time where we actually interact ourselves with PHP types. So this is exactly what I wanted to talk about, where we can interface with the PHP engine itself, and we have to figure out how to access values there. So a Zend hash table, or a reference to a Zend hash table, represents arrays in PHP. As you all know, arrays can be maps or like normal lists, and under the hood they are all stored as hash tables with some extra steps. Then we also need to tell our PHP crate that the first parameter is optional, so it is also represented in PHP as optional, so you can leave it out. So what do we do now with the configuration? We have our base configuration, which is the result of our old constructor. So just the defaults, minify true, easy. But now, because config is optional, we have to be sure that there's actually a hash table given as a parameter when we want to access it. And for that we use unpacking. Unpacking might be familiar to you from languages like JavaScript. And what it means is like applying the constructor in reverse. So a constructor for an optional value is sum with some value in it. But this is on the left side of a let. So let is an assignment, like a plain equals sign in PHP. And our config value is the option. And what this thing here does is it takes the config option and it tries to match it to this block. So if the config is sum, it will assign whatever is in this sum value to the variable config hash table. And now here's a feature that was only recently introduced in Rust. If this fails, we can have an else block. So if config is none, it cannot match this let block here, but then it will run this else block. And in this else block, we just return OK with the base transformer configuration. So what this means is, if you don't give it any configuration, you still have the same behavior, it will return the base one. Now we have to actually look into our config and apply it to Lightning CSS. For that, we have a for loop. So what this for loop does is, it creates an iterator from the hash table, which is also a nice feature provided by our extension crate. And then Rust automatically knows how to use an iterator, a bit like an interface, in a for loop. And this for loop will then iterate over the contents of the iterator, which are triples. This is again one of those complications with with PHP hash tables, is PHP hash tables are not purely based on key value pairs, but they also store the index so that you can also use them as a list. And what this does is again like unpacking structural matching. The iterator returns one triple after the other, and each of these triples will be then unpacked into an index, a key, and a value. And we prefix index with underscore because we don't care about numerical indices in our configuration. Now, because the key is optional in PHP, again, we also have to match it against our optional type, because, well, you can just insert a numeric key. And in this case, we wouldn't have a string key. So we match it, and again, we have an else block, but in this else block, we do the very not so proper way of just continuing with the loop, just whatever. It's data we didn't expect, but don't care. The error messages will come later. So with that key, we can then try and apply the configuration from our hash table to our config struct. And for that, we use a match block, which is not equivalent, but kind of similar to a PHP switch case. And this will, and also the PHP case thing where you actually return something. But it's similar to that. The idea is that you provided a value, and then you have a list of cases against which to match, and then it will execute the block that matches. So here we have our key, which is a string. We get it as a reference, because here's the next thing. These hard-coded strings in Rust, they are written as values in the library itself. So in the shared library file, there's a place for all the hard-coded strings, and this thing will evaluate just to a reference. And so we need to take a reference up there as well. With this reference then, we can match it, and if we specify a minify option, we actually care about the value. Now, the value is always there, because again, only the key is optional. And the value is of type Z value. And Z value means send value, which is how the PHP engine internally represents all the values and allows a strongly typed language like C to represent many different types of data, like strings, ints, floats, etc. And in our case, we want our Z value as a bool. Now the thing is, this cannot be like a Rust native cast, because the information what is contained in here is only available in runtime from the PHP engine. And so bool can also return a result, an error type. Or I think an option type. I don't think it actually throws an error. And what we use here is unwrap or default. This is also, again, like the easy way out to fit it all on a slide. In a real program, you would tell the user that, hey, you should pass a bool as a minify flag, not like any random value, and then just ignore it. What this means is, if the Z value contains a bool, it's okay. It will just unwrap the optional type from it and set base minify to this bool. In all other cases, it will ignore whatever went wrong and just return the default value for a bool, which is false. Again, kind of a dirty way, but at least it fits on the slide. So, and now we get to our last block, which is the actual targets thing. And here, we have a list of targets, so browsers and their versions as a string in the format of a semantic versioning. And for that, we first of all have to figure again out if our Z value, well, is actually a PHP array. And we can do that by just calling the array function and then checking like, yeah, okay, if this result is if this result is okay, everything is fine, it's great. If it's not error, we just tell the user like, hey, targets must be an array, you made a mistake there. This one fit on the slide. And then we again have the same pattern of matching a sum to get it out. I'm just trying to be very explicit here. You could write it way more terse, but then it would be harder to understand. I kind of want to reinforce the pattern. So again, an if let means, hey, if this works, just do it. If it doesn't work, then we could provide an else block here, but in this case, I don't actually want to do anything, so just let it run through. And then we get our Chrome version. Now the thing is how the browser versions are specified in Lightning CSS. It is fields per browser in a struct. This is not very dynamic, which is why we have to unpack it in a very verbose way. So we have our map, which is a Zend hash value again, a hash table, sorry. And then we just call the get function with Chrome. This is like a normal key lookup in a PHP array, like in PHP. And then we can map over our result type. So this can also return none, because obviously there's no guarantee that this key is in our hash table. But if this is not none, so if it were none, this is the if, and we just run off. But if this is some and contains an actual value, we want that value as a string. So in this case, we have the z-value string thing, and this is again the way in which Rust separates data from functionality. So the impl block for the z-val type has a function called string, and this function exists in the whole namespace of Rust, and you can just reference this function and then afterwards apply it to the data, so you don't have to know the struct in advance. And so once we have the semantic versioning string, we do some pure Rust code to take that string, explode it apart, and then bit shift it into an uint32, which is very fun because once Chrome hits version 256, this will break, but then again, that's not my problem, and Lightning CSS is still in alpha. Okay, so how does this look in practice? We can now define our configuration on the construction of our object, of our transformer object. We can then call the transform function, and we then get our minified CSS. So that's the technical part. Let's just wrap it up. As you can see here, these were people that were doing science back then. And we kind of want to do something similar. I hope I gave you all a seed to think about that. What we want is to learn about the nature of our environment. We want to know the nature of our work. Like, how does PHP work? We all do it in a way. And the other thing is that also, is kind of the standard thing of scientists is, no matter how exotic and toxic and horrible the thing is under the hood, you shouldn't fear it. You should have respect for it, definitely. Like, I'm not going out here and telling everyone, just implement everything from now on as an extension. That's obviously not a good idea. But I hope that now you're not thinking that's low-level stuff, this really ugly and horrible, but that you at least are curious how it works, and that if everything else fails, it is still an option. But there's also more concrete improvements there, because in all of development methodologies, I've stolen a bit from a philosophy of software design by John Ousterhout, which splits up development in tactical development and strategic development. And in the tactical sense, in the day-to-day writing of code, I think that knowing something like Rust, knowing different languages in general, will give you a better understanding of API design, because you are aware of requirements that aren't able to explicitly specify in PHP. For example, mutability, lifetimes, things like that. They are still important. There's just not a way to express them, and in some ways, they are managed by the engine. The other thing is the strategic programming. This is the more general kind, like designing systems, figuring the general gist of it out, building systems that are resilient and that do their job well. And in this thinking, what using crazy things like Rust PHP extensions is, it's just a new set of problems to solve. Things like, hey, you can't just assign that value, it has a different type. You can't just change a value. This is not mutable. Hey, these values are sync and async, and you can't share them across threads. Things like that. They make you they make you design systems with that in mind. For example, from my personal experience, handling Go and dealing with all of its async problems really made it easier for me to think about synchronization in my SQL databases, because also databases have to somehow synchronize data access. But it is something you don't really think all that often about if you're just programming PHP in the same old way. And last but not least, I want to tell you that this does have some real-world applications. For example, cryptography. If you have a fancy new cryptographic algorithm to hash passwords or hide some files or whatever, this is a way to use it. You can expose cryptography software written in Rust, maybe also having stronger safety guarantees, to PHP through an extension. You can use it to encode things. So maybe your advantage over a competitor could be that you can handle encoding of videos, photos, etc. during a request and not afterwards, because this will then mean you have a synchronous API instead of an asynchronous one. And also something that is dear to my heart, Rust also has quite a few cool graph libraries, and so dealing with graph data is also one of those ways we can use. So, with that, I want to say to you, go on, experiment, and thank you.
Thank you very much, Christian. Does anyone have any questions they would like to ask? We've got 5 or so minutes left. Yeah, you want to?
How much of the underlying PHP engine, things like class entities and such, does the library expose to it? So we've seen zvals there. What other mechanisms does it expose at this point in time?
At this point in time, it also exposes things like class structs in this case, class entries. Also, I think you have a way to get, you get the global class table. Things like that are also exposed. But to be frank, I didn't use especially a lot of the class features yet. So that's most of what I can talk about. Yeah.
Any other questions? No, I think that's it. Thank you again, Christian.
Thank you.
And everyone, it's time for lunch.